Good day, everyone. We are the Group 1 and we're going to present the basic laboratory techniques and operation. And the objectives are A. To learn the basic techniques in handling solid and liquids. B. To perform common laboratory operation.
For the materials and reagents, first, we will focus on materials. We have used the 6 test tube, glass rod, test tube holder, two 250 ml beakers, funnel, burner, test tube rock, graduated cylinder, watch glass, evaporating dish, hot plate, filter paper, triple beam balance, cubical tongue, spatula, test tube brush, and Ellen Meyer flask. For the reagents, we have used 0.5 m of sodium carbonate, 0.5 m of calcium chloride, sodium chloride, 1 H of hydrogen chloride, and 6 N of sulfuric acid.
And for the introduction, chemistry is a science that is learned through experimentation. It is dependent on careful surveillance, orderly operation, and the use of proper laboratory techniques. Laboratory regulations were created to serve as a guide in the development of efficient laboratory techniques. Complete adherence to the rules will ensure that all work performed in the laboratory is safe. The, master- the mastery of this fundamental operation is critical to the success and safety of any laboratory work. Also, essentially, research on natural environment components may begin in the field. It is usually completed in the laboratory. After obtaining a sample, the researcher or student must have been familiar with a variety of laboratory techniques in order to determine its properties. Some specialized techniques are required to determine the basic chemical and physical properties of the materials. And to our experiment number 1, there are 5 stations. Number 1 is handling of chemicals and reagents. It is essential to maintain the purity of the chemicals in the reagent bottles when removing solid and liquid chemicals from reagent bottles. Solely take out what you need and never return excess chemical to the stock bottle. Under the handling of chemicals and reagents, there are liquid reagents, which are the solution. Next is heating liquid in a test tube. And last is solids with powder and crystals. Next station is precipitation. Precipitation occurs when two liquid chemical substances interact with one another, resulting in accumulation of solid particles suspended in the liquid. The solid particles formed are known as precipitate. And the third station is filtration and decantation. There are two methods for separating a liquid from a finely divided solid suspended in it: filtration and decantation. And the fourth station is preparation of solution. For the production of a solution with a specific concentration of a substance, dissolve the desired number of moles of solute in enough solvent to generate the desired final volume of a solution. And the last station is evaporation. To separate a solid component from homogeneous mixture of solid and liquids, evaporation is used. Evaporation is the process of heating a solution until the solvent evaporates and turn into gas, leaving behind a solid residue.
We'll be discussing about the methodology of this experiment.
Next, handling of chemicals and reagents. A. Liquid reagents, solutions. So first, ready the materials. Materials such as glass rod, beaker, and ready the materials such as glass rod and beaker. Held the glass rod against the rim of the vessel, then gently pour the liquid on the glass rod to avoid spilling any liquid in the beaker. Another way of transferring reagents to a container is place the neck of the reagent bottle against the rim of the receiving vessel to transfer the reagent solutions. Next, B. Heating liquid in a test tube. Ready the materials such as test tube holder, test tube, flame burner. Then, using a test tube holder, hold the test tube and tilt the tube 45 degrees. Heat it by moving back and forth across the flame burner. And reminder, do not point the tube to anyone or look into the tube while it's being heated. Next. Sea solids, powder, and crystals. Ready the materials such as spatula, watch glass, triple beam balance, and reagents sodium chloride. Using a clean and dry spatula, spoon a pinch of sodium chloride in the reagent bottle, then weight the watch glass. Place the spatula, place the pinch of Na chloride in the watch glass, then weight again the watch glass with a sodium chloride. Then record and calculate the weights of salts. Next.
So for the second part of the experiment, which is the precipitation, the first step is to place the reagents into the test tubes. The reagents will be sodium carbonate, which is the NaCO, and calcium chloride, which is the CaCl. And for the second step, we will proceed to the process of shaking the test tubes gently. In this procedure, the interaction of two liquid chemical substances occurs. Then third, this will then result to the suspension of the solid particles. Then the precipitation will start and settle within the test tube. Then lastly, the separation will happen and the supernatant and precipitate will be the final result. This will happen in the third step, which is we will set aside the mixture for a few minutes. Next.
Filtration and decantation. Hindi ako natawa!
Okay na? Okay. 1, 2, 3, go.
Filtration and decantation. First, ready the materials. Materials such as circular filter paper, funnel, beaker, and the reagent calcium carbonate. Take a circular filter paper and fold it into half, then half again so that you get a cone shape. Open it up into a cone shape and place the conical filter paper inside the funnel. Place a beaker under the funnel and pour the calcium carbonate onto the funnel with the filtered paper to filter it. Decantation can happen in precipitation where solid is separated to the liquid. Next.
So for the preparation of saturated solution, first is we will prepare the solute and solvent. In this process, we will prepare a 10 ml of saturated salt solution, which is the solute, and the solvent will be water. Second step is we will add the solute to the solvent. We will place it into the beaker, and it will be the mixture in this experiment. And the third step is to proceed to the process of stirring the mixture, and we will mix it until the solute is fully dissolved into the beaker. Next. For the preparation of diluted solution, for the first step, we will prepare the concentrated solution and water. In this step, we will only prepare a certain amount of concentrated solution. For the second step, we will proceed to create the mixture, and for the third step, we will then calculate and measure the volume. Next. So for the dilute formula, the formula will be C1 V1 is equals to C2 and V2. For the second step, we will get the original concentration, which is the C1, and volume, which is the V1. Third step is to calculate, and fourth step is to the result. Fourth step is we will get the result of the new or the final concentration, which is the C2, and the new total volume, which is the V2. So for the for the third step, going back to the third step, um, the process of the calculation is we will substitute the given number according to the formula, which is the C1, V1, and the C2. Then, in order to find the total volume, which is the V2, we will multiply the C1 into the V1. After getting the result, we will then bring down the given of C2 and V2, V2 which is still unknown, or X. Then, in order to extract the X, we will divide the C2 to itself for it to be cancelled. Then for the next step is we will divide the C2 into the given result of the multiplied C1 and V1. And then lastly, we will get to the final result of the unknown V2, which will be the total volume of the experiment. Next.
Evaporation. Ready the materials. Materials such as evaporating dish, tripod, flame burner, then the reagent calcium carbonate. Transfer the saturated solution to the evaporating dish. Then place the evaporating dish to the tripod and put the burner under the tripod. Heat until the liquid disappears and only solid residue remains in the evaporating dish. Next.
Go na, Jade.
So let's move on to the result and discussion of the experiment. There are 5 stations of the observations, descriptions, and data. The first one is handling chemical reagents. A. Transferring liquid reagents. This section includes comprehensive instructions on how to measure precisely, pour, and transfer different substances in an exact, efficient manner while transferring liquid reagents. Next. B. Heating liquid in a test tube. This describes how to safely handle test tubes and their contents, as well as how to assemble and monitor their temperature in order to control the heating of test tubes and achieve the intended reaction and outcomes. Next. C. Getting solid reagents. This method includes selecting suitable containers, measuring and weighing items, and lowering the possibility of cross-contamination. The integrity of experiments and the safety of lab personnel are guaranteed by safety protocols and risk management system. Next. D. Weighing the solid reagents. The weight of solid reagents can be determined by subtracting the weight of the watch glass from the combined weight of the watch glass and sodium chloride. In this case, the weight of solid reagent is 1.2 grams. Next. The second station is precipitation. Precipitation is a process where two salts react or a substance solubility changes, results in the formation of an insoluble compound. In this test, 0.5 mole of sodium carbonate and 0.5 mole of calcium chloride were combined to produce precipitate, a solid produced by chemical reactions. The third station is filtration and decantation. Filtration, the physical process of filtering, uses a filter medium with an elaborate structure that only allows fluid to pass through in order to separate solid materials and fluid from mixtures. For this experiment, we use a filter paper, set it on a beaker, fill the filter with the contents of test tube 1 and then observe. Decantation, the act of decanting, separating the liquid from the solid and other impermeable liquids. In this experiment, gently move or separate the contents of test tube 2, taking care not to mix them. Don't combine any particle matter with the liquid that has been separated. The fourth station is preparation of solution. To create The fourth station is preparation of solution. To create highly saturated solution, gradually add the solute until it forms a solid precipitate or crystalline form. This homogeneous solution is set aside for evaporation experiments. Dilute solution decreases solute concentration by mixing more solvent like water to create diluted liquid reagents. Next. And the last station is evaporation. A heated solution is used in the process of evaporation to separate a solute such as salt from a solvent or such as water. Salt particles are left behind as the water vaporizes and evaporates into the atmosphere. There are several uses for this residue as salt. Pure salt is produced through effective separation of the solute and solvent by evaporation, which may be collected and used as needed. So let's proceed to the guide questions.
So let's now proceed to the guide question. Question number 1. What is the use of glass rod in transferring liquid reagents? The use of glass rod in transferring liquid reagent is preventing the liquid from running down the side of the vessel from which is poured. So in simple words, the glass rod is used to prevent the liquid reagent to spill and to transfer the liquid reagent smoothly to another container. Next question is, when heating liquids in a test tube, why does the test tube move back and forth across the flame? When heating liquids in a test tube, it is moved back and forth because, first, it is the proper way of doing such for the sake of the uniformity of heating the glass. Because if you don't do the proper way of heating the liquid, the test tube might break and cause harmful scene to anyone who's in the lab. Next question. Why should the spatula used for spooning solid chemicals from a reagent bottle be clean and dry? So, the reagent bottle is one of the primary apparatus which contain pure chemicals, and it should be pure as it is. Spatula should be clean as it used for spooning solid chemicals because negligence in maintaining the cleanliness of the object can contaminate chemicals in the reagent bottle, and it may result in damage and destroy the chemical properties of a particular substance or compound. Anything that is caused by negligence can result in serious and dangerous experiment in the experiment laboratory. Next question is, what is formed when calcium and sodium carbonate are mixed? So when you mix calcium chloride and sodium carbonate, it will produce a calcium carbonate. So next question. Compare filtration with decantation. Filtration works well with suspension or heterogeneous mixture containing fine particles. It entails passing a mixture through a porous barrier for separating the solid particles from the liquid. Filtration is a reliable option for filtering liquids. Decantation, on the opposite side, allows the liquid form to settle and removes the solid particles. Decantation is useful for quickly separating larger particles, but filtration is better for accurate separation of tiny particles that are concerned about purity. Next question is, which is more effective? Separating solid from liquids. In chemistry and other fields where purity levels are desired, filtration is the most effective method for attaining complete and constant separation. Next question is, what precautions should be followed in preparing dilute acid solution? The precaution to take when making a dilute acid solution should include the necessity of eye protection, acid storage, waste disposal, location, choice of acid, dilution technique, knowledge, labeling, neutralization, an emergency plan of action, and personal safety gear. Last question is, explain the use of evaporation in separating soluble solids. Evaporation is a separation procedure that involves heating a mixture to separate soluble solid from liquid. It involves heating the liquid component, causes it to evaporate into vapor, and then condense it to its original liquid state.
The students were able to familiarize themselves with laboratory materials and equipment, performing proper handling of chemicals and reagents. They learned basic techniques such as heating liquids in a test tubes, using triple beam balance in weighing salt or other substances, and etc. These simple techniques guide students for their first time in the laboratory, making them more knowledgeable. The experiment used filtration and decantation separation procedure to separate solid particles from fluid combination and liquid layers from immiscible liquid or underlying solids. Both techniques are useful for material separation and refinement in lab processes. In preparing a solution involves two methods, a saturated solution and a dilution process, providing precise control over solution properties and making them important in laboratory procedures. Overall, these basic techniques help students become more knowledgeable and aware in the laboratory.
Recommendation. Experiments require certain methodologies, which are basic laboratory abilities. These include operating gas burners and glasses, as well as pouring, measuring, and filtering. Anybody conducting an experiment needs to know about laboratory methods since they guarantee accuracy and precision at every step of the process. Technique, assist, prevent the risks associated with lab experiments. Many distinct operations must be carried out while working in the laboratory,
In
and each one calls for a unique set of abilities and methods. The use of reagents in laboratory operations requires precise measurements of the materials, taking additional caution when handling materials to avoid breaking of tools.
And that's all, the basic laboratory techniques and operation. Again, we are the Group 1 and thank you for listening.
Hello, madlang people.
Ted, wait lang.
Aisha!